Good evening. The Russian expedition to Mars is underway. On July the 7th, the first of the two probes lifted off on its way to the Red Planet. The idea this time is to survey not only Mars, but also the larger of its two tiny moons, Phobos, a midget world less than 20 miles across. The rendezvous is next January, and of course we'll have a great deal more to say about it then. But meanwhile, we've had what I regard as a very, very exciting picture. And this is the first really good view of Neptune taken from Voyager 2. It was taken on May the 9th, at a distance from Neptune of 425 million miles. And there's Neptune with this blue disk, and way over to the left, you can see a yellowish point. And that is Neptune's larger satellite, Triton, which is a fascinating world. It's a bit bigger than our moon. We don't yet know a lot about it. It's got an atmosphere of sorts, and we think that the surface may be covered with seas. Not oceans of water, but seas of liquid nitrogen. And we should know in August 1989 when Voyager 2 makes its flyby. And of course, we'll give that very full coverage in the sky at night. Meanwhile, there's been also an exciting event on the Sun, the biggest sunspot group for many years. And here it is. This is a lovely photograph taken for us by Douglas Arnold. And look at that huge group of spots there, much the biggest we've seen for some time. Now, this is the view you get if you do the sensible thing and use your telescope as a projector and send the sun's image through onto a screen fixed or fastened behind the eyepiece of the telescope. And if you do that, the sunspots appear to go very slowly from right to left, because the sun spins on its axis in rather less than a month, so a sunspot group takes something like a fortnight to cross over. And there is the view of that same group, lower down to the left there, taken a few days after the first. Now, how long it's going to last, I don't know. I had my last view of it on July the 9th, and you could just see the last traces of it as it went behind the sun's limb. It's now on the far side of the sun, and if it lasts for long enough, then it will reappear at the opposite limb later on in July. And I think it probably will, though of course with sunspots you never know. We've had another large group since then, and the sun is now well past the minimum of its cycle of activity, and we may expect many more major spot groups between now and round about 1989, 1990, 1991. Well, if we can look down the sky, let's begin, as we so often do, with the planets. All through the spring and early summer, Venus was a magnificent object in the western sky after sunset. And this was a view I had of it with my 15-inch telescope before what we call inferior conjunction, when Venus went almost between the Earth and the Sun. It's now reappeared in the morning sky, and if you get up early and look low down in the east, there you will see Venus. And you can't mistake it because it is so very brilliant. It's a weird kind of world, remember, about the same size as the Earth, closer to the sun than we are, and not the kind of world where you and I could live. Of the other planets, Jupiter is in the constellation of Taurus, not very far away from Aldebaran in the Hyades. And Jupiter also is extremely bright. I've had one or two reasonable views of it this year. This, I think, was about the best one. Remember, the surface is made of a gas. It's not a bit like Venus. There, to the upper left, you can see a hollow which indicates the position of the famous Great Red Spot, which is not well on view at the moment, although no doubt it will return. I may say that Jupiter is not very far in the sky now from the lovely star cluster of the Pleiades, or Seven Sisters. That's a view taken with a large telescope. You can see the nebulosity there. But even with the naked eye, you will see at least 7 individual stars. It's the most beautiful open cluster in the sky, and I always think, you know, that when the Pleiades start to become on view in the late evening, that indicates the onset of winter with its fogs and frosts, but that, luckily, is not quite yet. And then we have Mars, below the square of Pegasus, getting brighter, and of course, always recognizable because of its strongly red color. I haven't had many good views with my telescope. That, I think, is about the best one, taken earlier this month. You can see there the white ice cap, and that dark triangular area that we call the Syrtis Major. But Mars is getting closer all the time, and this September is going to be within 40 million miles, and that's just about as close as Mars can ever get. It won't be as close again for the rest of the century, and so obviously we're going to devote the whole of our September program to it. And then, finally among the planets, there is Saturn. Rather low down in Sagittarius, the Archer, not far from the bright red Antares in the Scorpion. And although Saturn is inconveniently low, the rings are wide open. And that's how I saw it the other night, and there's no doubt in my mind that Saturn is the loveliest object in the entire sky. Toward the end of July, we'll start to see the first of the Perseid meteors, and there's a photograph of one. It was a time exposure, so the stars appear drawn out into trails, and there is that meteor trail from top right to bottom left. Of course, the meteor itself was gone in a second or two. But I won't say any more about the Perseids now, because we're going to devote the whole of our next program to them, and they should be particularly good this year, because when the shower reaches its maximum on about August the 12th, the moon's going to be out of the way. So let's turn now to the stars and begin, quite conventionally, with Ursa Major, the Great Bear or Plough, which never sets over Britain, so you can always see it somewhere whenever the sky is sufficiently clear and dark. And you can use the pointers to find the way to Polaris, the pole star, which lies within 1 degree of the polar point of the sky. And so Polaris appears to stay almost still, with everything else going round it once in approximately 24 hours. And you can also find Ursa Minor, the little bear, which looks like a rather faint and distorted version of Ursa Major, curving down over the Great Bear's tail. But in Ursa Major itself, look at the second star in the plough handle, the tail of the bear. It's called Mizar, and close by it is a much fainter star called Alcor, which really does make up the same kind of family party. And here's a photograph of Mizar and Alcor taken by Commander Hatfield. But if you have a telescope, then you will see that Mizar itself is made up of 2 stars, so close together that with the naked eye they'll appear as one. They really are associated. They're going round their common center of gravity, though they take many thousands of years to do so, and they form a typical binary system. There are plenty of binary stars in the sky. Mizar is a particularly good example. Now, let's go back to our map and find something else. From Mizar, extend an imaginary line through Polaris, and then you will come to Cassiopeia, the lady in the chair, which looks rather like either a W or an M, whichever way you look at it. And the stars in the W, the 5 of them, are made up of stars which are between magnitudes 2 and 3. And I think at this stage I must say something about magnitude. A star's apparent magnitude is a measure of its apparent brilliancy. I don't mean its real luminosity. Remember, the stars are not all the same distance from us, and therefore a bright star may look bright either because it's really very luminous or because on the cosmical scale it's pretty close. So a star's apparent magnitude is merely how bright it looks to us from Earth. And the scale works rather in the way of a golfer's handicap, with the more brilliant performers having the lower values. So bright stars are of magnitude 1, 2 are fainter, 3 fainter still, and so on down to magnitude 6. And those are just about the faintest stars you can normally see with the naked eye on a clear night. Binoculars will take it down to around about 9, and telescopes down well below 25. And of course there are also some stars brighter than magnitude 1, and they have 0 or even negative values. Now the pole star is almost exactly of magnitude 2, and so are the stars in the plough, some a bit brighter, some a bit fainter, and only one of the 7 plough stars is definitely fainter, and that's below magnitude 3. Now in Cassiopeia we have stars between just below 3, the top one, and just below 2. But the middle star, which is called Gamma Cassiopeia, is not steady and constant. Most stars, including our sun, luckily for us, shine steadily for year after year, century after century. But there are some which don't. These are the variable stars, and Gamma Cassiopeia is one. It's unstable, and periodically it throws off shells, which we can't actually see, but which make the star brighten. And it can go up to magnitude 1.5, much brighter than the pole star, or it can go down below magnitude 3. Generally it's just below 2, and it is at the present moment. Also look at the star we call Alpha Cassiopeia or Shedia, and that may be very slightly variable, not very much, but if you use binoculars, you will see it's quite definitely orange, unlike the other stars of the W, which are white. And that indicates that Shedia has a cooler surface than its companions and is in a more advanced stage of evolution. But there are plenty of other orange stars. Let's find a really bright one. Let's find Arcturus. Follow round the tail of the bear or the handle of the plough, and there you will come to Arcturus in Boötes, the herdsman, which is a really brilliant star, actually slightly above magnitude 0. And it's actually the brightest star in the northern hemisphere of the sky, apart from Sirius. It's a lovely orange colour. It's 36 light years away from us, and it's one of our nearer neighbours. There's not a lot else in Boötes, but not far away we'll find the little semicircle of stars marking Corona Borealis, the northern crown. And that's only a small constellation, but it is a very interesting one, and it contains one object of special note. The brightest star is Alphecca, which is an ordinary star, a white one, just below magnitude 2. In the bowl of the crown, with binoculars, you will generally see two stars. One I've labelled M there, this is our name for it, and the magnitude there is 6.6, so it's rather below naked eye visibility. You will generally see another one, and this is the famous variable R Coroni, usually round about magnitude 6, just on the fringe of naked eye visibility. But at totally unpredictable intervals, it falls down to a minimum, taking a few days or weeks to fade down, and becoming so faint that even moderate-sized telescopes won't show it. It remains faint for a period, and then slowly and rather irregularly recovers its lost light. And from that we can draw up a light curve of plotting magnitude against time. And this is a dip that I observed myself actually way back in 1972, but it's rather a good typical one. And you can see there that from magnitude 6, over a period of something like 70 days, it faded down below magnitude 12, that's out of binocular range, and then it very slowly recovered. And it may do that at any moment. So if you look at the bowl of the crown and find only one star there, not two, you will know that R has started to go down to minimum. And why? Well, it genuinely is variable. It's not like other stars, or most other stars. It doesn't contain so much hydrogen, but it contains a great deal of carbon. And we believe that periodically clouds of carbon accumulate in the star's atmosphere. In other words, clouds of soot. And so R Coroni hides itself behind clouds of soot. And that lasts until the radiation coming from below blows the soot clouds away and the star regains its light. It's not unique. There are other R Coroni stars, but not very many of them, and R Coroni is the brightest. So have a look at the bowl of the crown. If you only see one star, you'll know that R Coroni has started to fade. Well, now let's look at something different. Let's go back first of all to the northern crown. There's Alphecca, and Vega, the leader of the unofficial summer triangle, the brilliant blue star, magnitude exactly 0, almost overhead after dark. And between those two is the rather ill-defined constellation of Hercules. Now, in mythology, Hercules was a hero. In the sky, he's not very bright, but there is one fascinating object there, the globular cluster M13, Messier 13. And that is just visible to the naked eye, if you know where to look for it. Binoculars show it easily as a kind of a smudge, and with a telescope, you can resolve it into stars. That photograph was taken with a big telescope, but even a small one will resolve the outer parts. And it really is a huge symmetrical star system made up of something like 1 million stars and more than 18,000 light years away from us. And I just wonder what it would look like if we lived on a planet going round a star some way outside it. And that's an impression by Paul Doherty, and it might look rather like that. But of course it is a long way away, and all the globular clusters are. They form a kind of outer framework to our main galaxy. Our galaxy is disk-shaped, as you know, and the globular clusters and isolated stars form a kind of galactic halo. So they're all very distant indeed, and they're also rather old by cosmical standards. There's one other very interesting object in Hercules, and this is Ras Algethii, or Alpha Hercules, variable between magnitudes 3 and 4, and rather away from the main Hercules pattern, and actually quite close to a white second magnitude star with a rather similar name of Ras Al Hague. And Ras Algethii is a huge red supergiant. It's much bigger than the Earth's orbit around the Sun. Here's a representation of the path of the Earth. Sun in the middle, Earth going round. Remember, the Earth is 93 million miles from the Sun, and so the diameter of the Earth's orbit is 186 million miles. And the huge globe of Ras Algethii is larger than that. It could swallow up the entire path of the Earth around the Sun. No wonder we call it a supergiant. It's a very old star that's used up its main fuel and has now become unstable, in the way that all stars do when they use up their main source of nuclear energy. And that's why it varies rather irregularly between magnitude 3 and 4. And what variable star observers do is to compare it with stars which don't vary. And there are quite a number of those round, but I think the most suitable one is this one, which we call Kappa, in the neighboring constellation of Ophiuchus the Serpent Bearer, which is just below magnitude 3. Sometimes Ras Algethii is a bit brighter than Kappa, sometimes rather fainter. The variations are slow, but they are noticeable. Also, Ras Algethii is not a solitary star. It has a binary companion, which is actually white, but looks rather green by contrast. you can see it with a small telescope. And if we lived on a planet going round Ras-el-Gheti, I wonder whether the view would be anything like this. I have a feeling it probably would. Mind you, I don't think Ras-el-Gheti is the kind of star to have an inhabited planet going round it, but I suppose one never knows. Now let's come back to the general area of the summer triangle. Vega's there, Cygnus the Swan, and here is Altair in Aquila the Eagle, which has a fainter star to either side of it. And below Altair, there's a line of 3 stars, and 2 of these, Delta and Theta Aquilae, are perfectly ordinary stars of about magnitude 3.5. The middle one, Eta, is another of our variables. It's what's called a Cepheid variable. It ranges between magnitude 3.5 and 4.5, and it's perfectly regular. And from that we can draw up a light curve. And this is a typical light curve of Eta Aquilae, ranging between magnitude 3.4 and 4.7, and the interval between one maximum and the next is 7.2 days. It's what's called a Cepheid variable, and it's very valuable to astronomers because these Cepheid variables are perfectly regular and they give away their real luminosities by the way in which they behave. The longer the period of variation, the more luminous the star. And so if you know how bright it looks and how long it takes to vary, you can work out how luminous it really is, and from that you can find out its distance. So these Cepheids are invariable standard candles to astronomers. Below Aquila, there's a small constellation of Scutum the Shield, and there we have another cluster, Messier 11. Not a globular this time, a loose cluster, a lovely sight in a small telescope, and it's been nicknamed the Wild Duck. And when you make a drawing of it, I suppose you can make a kind of duck shape out of that. It really is rather a lovely cluster, even though I think the duck form is a bit hard to make out. And close to M11, there's another of our variable stars. This is R Scuti, which is usually just below naked eye visibility, has a rather indefinite period with alternate deep and shallow minima, and you can follow that with binoculars. I've already mentioned Sagittarius, the Archer. Rather low down in the sky, that's where Saturn is at the present moment. And that's where we find the lovely star clouds which hide our view of the center of the galaxy. And if you have binoculars or a low-power telescope, do sweep about among those star clouds, and I think you'll find they are tremendously exciting objects. Now, I've got 2 more variables for you, so let's go back now to our original map. There's the Great Bear, we found Polaris and Cassiopeia, and here is Cepheus, the king. Not a very conspicuous constellation, but with 2 interesting variables. One of them is Delta Cephei, the prototype Cepheid, the first one to be discovered. Again, varies between magnitude 3 and 4. Compare it with Zeta, just below magnitude 3, and Epsilon, just below magnitude 4. And you can see it varying from one night to another, period just over 5 days. And the other is Mu Cephei, which is much fainter, about magnitude 5, but when you look at it through binoculars, you'll see it really is intensely red. So William Herschel called it the Garnet Star. It's actually a huge red supergiant, even larger than Ras-el-Gheti, but of course a great deal further away. And it well earns its nickname, I think, of the Garnet Star. So there's plenty to see in the summer sky, and it's time now for our newsletter. And if you like it, then as usual, send your stamped addressed envelope to newsletter number 30, The Sky at Night, BBC TV, London W12 8QT. And you can also find details on CFAX, page 186. And so, until next month, when I'm going to talk to you about the Perseid meteors, good night.
Tonight's tour of the summer sky at night can be viewed again on Saturday evening at 5:40 on BBC Two.